Hi everyone. In this demo, we will demonstrate how we can use D2iQ DCOS and the new data science engine service with multiple other services to create a modern data science pipeline. I've deployed DCOS in AWS on multiple nodes. Like you see there are like public agents where we run the load balancers, and private agents where we will deploy multiple workloads. And as you can see, I've already deployed many things. And some of them are also having GPU. So you can see we have a total of 136 cores, more than 100 gigabytes of RAM, and 3 GPU cores. Using the service catalog, I've deployed HDFS, the new data science engine, and multiple services like you'll be able to see. Very easily, just describing the way it works. You click on one service, you select the version of the service you want, you define the different parameters in terms of security and in terms of specific to the application, and you can even get the JSON version of that. So what I did here is that I used scripts that leverage these kind of JSON files to automate the deployment of all the services I need for the demo. So here you can see I deployed the demo under different directories. So that's the way you can get a multi-tenancy out of DCOS. And here in the prod directory, I have like a data service directory, and as you can see, I deployed HDFS cluster. This cluster is secured with Kerberos and TLS, and it's very easy to set up, as you can see. I deployed also Kafka Zookeeper and Kafka itself, and I deployed NiFi. I deployed a Spark cluster as well, and also deployed a Kubernetes cluster. Like you can see, version 1.15.1, which is very recent. Probably very few vendors support that version already, and also deployed Gitlab, Jenkins, and a private Docker registry. So the idea is to go through several demos so that you can see the benefits of having all of these services in the same platform. But before we go through the demo, let's speak quickly about DCOS. So DCOS can be deployed anywhere, on any cloud provider, on-premise, on OpenStack, VMware, bare metal machines. We just need Linux machines. So you really avoid lock-in and you get the same experience anywhere. Then we use the Apache Mesos layer to aggregate all the resources of these machines, including GPU. And we run multiple workloads on the same machines so that you get a better utilization of these machines. So you reduce the infrastructure cost. Then we have like this catalog of services like Kafka, Cassandra, Spark, Jenkins, and so on, that you can easily deploy, maintain, upgrade, and you get support from us. So you really reduce the management cost and you get a faster time to market because now you can just focus on using these services instead of trying to deploy and maintain them by yourself. So in the first demo, we'll use like Spark to create a model that classifies spams and non-spams. So in this case, what we'll do is that we will get some spams in a text file. We'll generate a model with Spark, and we'll store this model in HDFS. And we just leverage, in this case, the DCOS Spark service. We don't leverage Jupyterlab yet. Like you can see, everything is secured with Kerberos and TLS. So we have like a command line DCOS CLI that has this extension when you install Spark, DCOS Spark run, equivalent to a Spark submit. We have some parameters that we need because we have this security in place, like I described before, and also some options about where to find the text file with spam hams and where to store the model in HDFS. So I just run that script, and that will launch this Spark job. And you can see here in this COS you have access to the Spark UI. If I go there under Spark, you see get the UI, you click there and you get this UI here, and you can see that this is currently starting. And if you go to the Mesos UI, you'll see also that the driver is just has just started. So we just wait for a few minutes and we'll get the model ready. Okay, so now that the model is ready, the next step of the demo is shown in this slide. So we'll use another Spark job to generate messages into Kafka. And we will then after be able to classify these messages. So same idea, we go through the command line, and in this case we use another script that's also leverage the DCOS Spark command line. But in this case, we get a little bit more parameters because we also want to communicate with Kafka, with TLS, and so on. So I just execute this script, and we can go back to the Spark UI, and we'll see that there will be a new job starting. So let's wait just a minute or so. And as you can see now, the job is running, and we start to have messages produced in our Kafka topic. So now what we want to do is to consume these messages and to apply the model. And we want to take a different approach in this case. We want to use the new data science engine service, and that is leveraging Jupyter, to show you how to do that with a notebook experience. And in this case, we will not leverage the Spark service from DCOS directly. We will leverage the Spark driver that is running inside the Jupyterlab notebook. So as you can see here, we have a Jupyterlab notebook. It's one instance of the data science engine. It comes with multiple kernels that allows the data scientist to use the language he wants, like R, Scala, Python, and so on. And everything is integrated with Spark, with TensorFlow, with security. Here we have like a Kerberos environment, and if I just do a K-list here, I can see I'm already authenticated as this principal, and I have this ticket created for me. So whatever I will do will be done with these credentials. So let me open this notebook here. We will have like few things to run before, just to define some functions and to import some libraries. And after that, we'll be able to go through this code that will connect to the Kafka topic. Like you see, this is the highest level of security, SASL, SSL, and we'll go through this topic, get messages, and try to evaluate the accuracy of the model when it classifies these messages from Kafka. So we just click on run, and what will happen is that it will start a distributed Spark job. As I said before, in the data science engine, there is a Spark driver running automatically. And when we launch this job, then it will use resources in Apache Mesos to launch the executors and to leverage resources from the cluster. You could say that if you do that and all data scientists are leveraging the resources of the cluster, then you get some problems because everyone starts to abuse about the resources they use. But the good news is that you have this ability to set quota, like you see I've done here. For this data scientist, there is like a limit of 7 CPU and this amount of memory. And I just launched 4 executors, 1 CPU each, and you see the consumption in real time. We just need to wait a little bit for the Docker image to be pulled and for the job to run. Okay, so now like my job is running, and if I go back to the notebook, I can see that the accuracy is displayed in real time. So it's pretty nice. As you can see, we can use Jupyterlab to provide a notebook experience. We can leverage additional services from DCOS like Spark, Kafka, and HDFS to create a secure pipeline. But we can do much more. And in fact, when we look at modern data science projects, people try to do much more and try to get some of the benefits of DevOps and apply that to their data science projects. And that's why we start to speak about data ops. And in this case, we have another demo that shows that in, a, in a nice way with multiple additional components. In this demo, what we'll do is that we will also introduce the ETL part with Apache NiFi, and we'll get some pictures from the Flickr API, pictures of cats and dogs. Half of the pictures will be stored in HDFS. The other half will produce the corresponding URLs in Kafka topic. Then we'll not use Spark in this case, we'll use TensorFlow, and we'll retrain an image classifier to be able to classify this picture of cats and dogs. Again, we'll use Jupyterlab Notebook for that. But in this case, when the model will be ready, we will push it in a GitLab repository, and we will configure a CI/CD pipeline using Jenkins to push our new model in production on a Kubernetes cluster. Okay, so let's get started. So first of all, let's log in NiFi again with our principal. Everything is again secured with Kerberos, TLS, and you'll see that also when we use the template. So we have a template we upload, which is just there. And as soon as we have uploaded this template, we'll just add it here to our workspace. And one thing you cannot do is storing password in these Flickr templates. So we'll have to do a few quick modifications so that you'll get this password configured. So at the same time, I also explain you about the workflow. So we have twice the same workflow, one for cats, one for dogs. Here you see you have this warning because the password is not set. So in this step, what we do is that we get the pictures from the Flickr API, and we use SSL context because it's a secure communication. So we just need to put the password here, and we can activate it. Then here we go through the different pages of results we get, and for half of the results we'll store them in Kafka. Again, here we use SSL, SSL, and all the Kerberos authentication and so on, but again we need to set the password of the trust store here, so we just do that quickly, and we enable it. And then the other half is stored in HDFS, and again I can show you here that in this tape everything is secured with all the credentials with Kerberos and SSL. So I just need to update the last password here like I did in the first workflow, and we'll be good to run it. We enable it, and we'll be able to launch everything here. Just select all and click on the play button. So while this is running, we can set up Gitlab and Jenkins quickly. So let's start with Gitlab. just define a default password, and then we log in with this password, and we create a new project here, new repository. We'll just put it public for the purpose of this demo. And this repo is currently empty. So next step, we go to Jenkins, and we just have to update a few things there because some of the plugins there are outdated and we need to use them. So we just quickly select pipeline API and pipeline step API and say we want to download them and we want to have it restarted automatically. So now that it's updated, we can go and click on Manage Jenkins and update a parameter to be able to communicate with our private Docker registry. So we just go at the bottom quickly and change also the default value, because when we have a pipeline executed, it will launch a job on Mesos, but we want just to keep it for longer time so we don't have to rebuild the Docker image many times. And as I said, we just set an environment variable here that we need to be able to communicate with our private Docker registry. We just have to apply and save that. So now we can go back to our Jupyterlab notebook. And one thing that is interesting to note is that our executors are still running there. That allows you to iterate very quickly in your code and try some modifications. But in this case, we don't want to continue with this demo. So we just need to go in the kernel and click on kernel, shutdown kernel, and it will release the resources in Mesos, and that will release that also in the quota utilization of this user. So we go to this Jupyterlab notebook, and we have another notebook here. We need to check how many pictures we got so far from NiFi, stored in HDFS, and we need to wait to get like a number that doesn't change anymore, around 2000 or something like that. So let's just try to run it several times. And then we also configure our first commit in our GitLab repository by just executing these few lines of code. And this doesn't contain the model because we didn't retrain it yet. So if I go in my repository here, I can see I have my first commit, but I don't get all the models that is called output something. So let me check again. We don't have more files coming here. 2043, so we are probably near the end. Okay, we are good. It doesn't change anymore. So we can now get the Python script that will allow us to run our TensorFlow job to retrain the model. And the beauty of this retrain in TensorFlow is that it allows us to create a classifier without having like millions of pictures, because we already have layers that exist that will be leveraged to get a quite useful model with only like a very small sample of images. So we can just click there and run this TensorFlow job. And this is just like a local TensorFlow job, and we'll see in another demo how we can use distributed TensorFlow jobs. So it will take a while To retrain this model, in the meantime, we can create the Jenkins CI/CD pipeline. So we just go on Jenkins, click on new item, and just say it's a pipeline. And then we want to execute this pipeline every minute. So we just use a cron tab notation to express that. And then here we want to say we check the Git repository. And we just select the credentials, click on apply, and the first time when it will execute, it will fail because it will not find the model. But as we changed the timeout before, it will fail, but the executor will keep running so that when we will push the model later, it will be quite fast to rebuild the image. So as we can see, the pipeline has started, and if we click on it and we click on console output, we can take a look at the progress. And here we are rebuilding, recompiling the Kafka Python module to support Kerberos and SSL, so it takes a little bit of time. So as expected, the pipeline fails when it tries to find the model files. So now we can take a look in the notebook and see if it's finished. Yes, it has been retrained. So we get our model ready. We can even take a look at that in the TMP directory. We should get our two output files, one with the label and one which is the model itself. So we go back to the notebook here. At the very bottom, we can even, in fact, clear the output of that. And we just add these output files in the repository and we just push them. So just click on that. It will just take a second, and we'll get our file now in the repository, and we'll be able to check that on GitLab in a second. The two files have been pushed. I go to my repo here. I see the model there, and we'll see that Jenkins will discover that automatically, and we'll run the pipeline again. The executor is still there on Mesos, and we can even check that here. If I go to Jenkins, I see I have my executor here, my task. And if I go to Jenkins here, go to the output, I'll see that very quickly I'll be back at the same stage where the output file was missing, and I'll be able to continue and finish the creation of the Docker image that contains the model, and then push this Docker image in our private repository. So we see the model is being added now, as well as a few other files, and finally the Docker image will be pushed to the repository. Okay, so the image has been pushed, and the deployment created on the Kubernetes cluster, like we see, it's a success. So we can see here our Kubernetes cluster, and we can see the deployment is up and running. Automatically, it has created a service type load balancer for us using our HLB service, and we can access the application through the public nodes. We just need to add the corresponding ports, and we have our UI here, and the idea is that we can now just submit a picture of a cat, for example, and see that the model works fine, and it discovers it's a cat. And we can also even, like you've seen in the diagram, start to consume the pictures from the Kafka API and being able to classify in real time the picture of cats and dogs. So we ran a TensorFlow job, but it was a standalone TensorFlow job. So what about a distributed TensorFlow job? For that, we leverage a project from Yahoo called TensorFlow and Spark. And we'll do that using the MNIST dataset and training a model using this dataset. And we'll start by doing that on the same Jupyterlab notebook. So again, we just go there and shut down the kernel. And we can now open that file. We just clone the TensorFlow and Spark from Yahoo here. Then we'll just like get this MNIST dataset and unzip the dataset. Make sure that there is nothing for the moment in HDFS, and submit a distributed Spark job to be able to store all of these datasets in HDFS. So again, just click on the play button and automatically we'll see on Mesos that we'll get the new executor being started in a second. So we see the job is now running. So when the job is finished, we can see that all the output is displayed in a notebook here, and we can just check that the dataset is present in the HDFS file system here. And that Spark job is a little bit different because, as you can see, we leverage TensorFlow and Spark to distribute the TensorFlow job, and we'll set up the cluster size to the number of executors we want to use. So we just execute that, and we leverage the Spark framework to distribute the job across multiple executors. So when we run it, we'll see again this executor being launched on Mesos, and we'll be able to take a look at the output to see it progressing. So we see it has to get to the 10 steps there. So we see the job is finished now, and we can take a look at the HDFS cluster and make sure that we see that the model has been created correctly. So next step will be to do exactly the same, but with GPU. So as you can see, same diagram, but we just use GPU. So we have another Jupyterlab notebook and a very similar notebook here. The difference you can see here is the number of GPU we leverage here for the executors to accelerate the training of the model. So, and we use different directories just to make sure that we don't have conflict with the other one. So we just again do the same step, cloning the repo, TensorFlow and Spark repo, and getting the dataset and zipping the dataset and running a Spark job to get this dataset stored on HDFS. And if we look on Mesos there, we see that we have these jobs running, and we can also see that these two GPU are now in use. And if I go to the main DCOS dashboard, I can also see that now I use my 3 cores, one for the notebook itself for the driver, and 2 for the executors. So now that the job is finished, we can check that the dataset is now present in HDFS in this directory here. And then we can start to create the model using our GPU. So we have only 2. Just update that and click on play, and it will start the job. And we can check the progress in the same way. Here we have the same 10 steps to cover. As soon as the job is finished, we can simply take a look at the HDFS file system and make sure the model has been created. Like you can see it's down, we can shut down the kernel. Always a good practice to release the resources. So what have we demonstrated with all of these demos? So we demonstrated that D2iQ DCOS provide all the software you need for your data science projects. Also that you can deploy each of them in a few minutes just with like I described before. I have a script that deploys like all these HDFS and Spark and data science engines and so on. We can secure all the communication with Kerberos and TLS, things that are quite difficult to do normally, but everything has been really simplified with DCOS. You get the same experience anywhere in the public cloud, on-premise. You get the notebook experience for the data scientists, but instead of having the notebook running on their workstation with a very limited amount of resources, they can use the resources available in the DCOS cluster. You can leverage GPUs to accelerate your model training. You can leverage quotas to guarantee resources, also to avoid abuse from one data scientist who would use all the resources of your cluster. And then you can also even like use tools like Gitlab and Jenkins to create a CI/CD pipeline, leverage Kubernetes to serve your model in production, and so on. Thank you for watching this video. Hope it was useful to you.